So the first thing we're looking at today is the square root of a negative number property. The first part of it states if r is a real positive number, then the square root of negative r is I square root of r. By the first property, it follows that I square root of r squared is equal to negative r. Well, if there's a negative inside the radical, it's going to come out as I. We can just pull the negative out as I. And if we square it, we'll get right back to the negative number. So really what this is saying, if we have the square root of negative 3, well then this is I square root of 3. And if we square I squared of 3, we'll just get back to negative 3. Part 1 and part 2. That's really all that's saying. And what we're going to do today is actually solving with imaginary solutions. Is what we're going to start off with. Solve the quadratic equation. Well, here we have x squared plus 4 equals 0. Well, since we do have an x squared, a variable that is squared but no other variables, we can solve this by the square root method. So our first step is we can subtract 4 from both sides, which tells us that x squared is equal to negative 4. Now what can we do next? Square root both sides. The square root and square would cancel, leaving us with x is equal to I square root of 4. But what is the square root of 4? So x is equal to plus or minus 2i. So we can say I square root of 4, which is just 2. Questions on this here? Because that there would be the answer, both of them. All right. Let's look at the next one. 2x squared minus 11 is equal to negative 47. Well, again, x squared is the only variable, so we can still use the square root method. Since we're using the square root method, we want to get x squared by itself. What can we do first? Add 11. And if we add 11 to both sides, we'll get that 2x squared is equal to negative 36. And then what would we do next? Divide both sides by 2, which tells us that x squared is equal to negative 18. And our next step would be to square root both sides. Because the square root of x squared, well, the square root and the square would cancel and give us x is equal to plus or minus. Because square root of negative 18, we would pull out the I, leaving us the square root of 18. Is 18 a perfect square? No. But there is a perfect square inside of 18, which would be 9 and, because what's the square root of 9? So 3 would come out, I, and we're left with the square root of 2. So we have 3i square root of 2. And that would be the answer. Now the yellow calculators, the TI-30XS, will do the square root of 18, and it'll tell you that it's 3 square root of 2. It will simplify those for us. And we do always need the plus or minus when we square root both sides. And on Friday, the first thing we talked about, or Thursday, we talked about the zero product property, or sorry, the complex conjugate property, which said if a plus bi is a solution to the equation, then a minus bi is also a solution. So if 3i square root of 2 of us is a solution, its conjugate, negative 3i square root of 2, is also a solution. If we have one, we have to have the other. Any other questions on this here? 4x squared plus 20 is equal to 0, or 4x plus 20 is this here. Well, if we want to find the zeros, we're just setting this equal to 0. What would we do first? Well, we would subtract 20 from both sides, which will tell us that 4x squared is equal to negative 20. We're going to divide both sides by 4, which tells us x squared is equal to negative 5. And last but not least, we would square root both sides, which will tell me that x, because those cancel, is equal to plus or minus. Well, the negative would come out as is 5 prime. Yep. So x is equal to plus or minus I square root of 5. Questions on this here? Solve x squared minus 16x plus 64 is equal to 100. This one here is a little bit special. We're going to cover one of these here. We'll see 2 of them on the assignment, but there's another way that we can do these. And it's dealing with the fact of what x squared minus 16x plus 64 is. Because if we look at this here, x squared minus 16x plus 64, let's just factor it and see what happens. Now there's not a greatest common factor, so we'll have our 2 sets of parentheses with 3 spaces. Now since the third term is positive, the signs are the same and they match the sign of the middle term, which would be negative, so they're both negative. Now we need to find the factors of the first and third term. Well, the factors of the first term are, and what factors of 64 would we use? 8 and 8. Now, up till now, we would do this, but we would have the thing equal to 0. Because then we could say, well, 2 things multiplied together equals 0 means one of them has to be 0. But if we look at the first, these sets of parentheses, we'll have x minus 8 and x minus 8. They are the exact same thing, yes? So I could rewrite this as x minus 8 what? Squared is equal to 100. So if I could rewrite the polynomial so that I get a set of parentheses squared, well, now we can use the square root method, yes? Because I have a set of parentheses squared is equal to something else, so we could square root both sides, because the square root and square would cancel, leaving us with x minus 8 is equal to plus or minus 10. Because whenever we square root both sides, we have to add the plus or minus to the one side. Is x by itself? Well, no. We need to do what? Add 8 to both sides. which tells us x is equal to 8 plus or minus 10. Any questions on this so far? Can we do 8 plus 10? Well, 8 plus 10, we can add those together, yes? Can I do 8 minus 10? Oh yeah, we can add, subtract 8 and get numbers. So we need to do that. Well, 8 plus 10 is? 8 minus 10 is negative 2. And that would be our answer. Now, if the radical doesn't simplify all the way down, or if we have imaginary terms I, we can't add or subtract them. Because instead of getting 10, if we got 10 square root of 2, well, we can't do 8 plus 10 square root of 2 and get a number, a whole number, or 8 minus 10 square root of 2. So we can leave it in the plus or minus form. But here, we can do 8 plus 10 and 8 minus 10 and get a number. We're going to go on and simplify it. Questions on this here? We good with this here? Now, this property is quite nice. Because if I could rewrite any polynomial so that it's a perfect trinomial, to where I could rewrite the polynomial as a set of parentheses squared, that would make things a lot easier, because then we can have it as a set of parentheses squared, square root both sides, and solve. But as we've seen so far, will every polynomial work out this way? Well, no. So what we have is our next method of solving, which is completing the square. And what the main property behind this is that we are going to manipulate the equation by adding and subtracting stuff to both sides so that the polynomial itself is a perfect square trinomial, one that we can rewrite as a set of parentheses squared. Then we could square root both sides and solve. Now, to do that, there are several main parts, and the first part is finding the constant term that will make this a perfect square trinomial. Now, it works out that C is equal to B over 2 squared. The constant term, the C value that we need for this here, is equal to B over 2 squared. Now again, this is working off the fact that the standard equation is ax squared plus bx plus c. They want us to find b, what the value of, what the value of c is, and then express it as its trinomial, perfect square trinomial. Or really express it as a square of a binomial, like we had on the last one, 8 minus x squared. We want to rewrite it like that. So, looking at this here, c is equal to, the constant term that we need is b over 2 squared. What is the value of b? Is it positive or negative? Positive, because when we take the value of b, we will take the sign with it. Okay? 14 divided by 2. 7 squared is 49. So our perfect square trinomial would be x squared plus 14x plus 49. That is the perfect square trinomial. Now, we need to write it as the expression, then write the expression as the square of a binomial. So we want to rewrite it as a set of parentheses squared. Well, we know the variable is what? X. How did we get that? 49 squared is 7, yes? And then since it's positive, the signs are the same and they match the sign of the middle term, yes? Where else do we have positive 7 written here? Right here, yes? It works out that the sign and number before we square it will be what goes inside. Because we'll have x plus whatever that is, or minus whatever that is, to give us that part. So for these problems, and there are a few of them that I'm going to have you do on the homework, that's all you're going to have to do. So find out that the C value is 49, and that the expression as the square of a binomial is x plus 7 squared. We need those two parts. Let's look at number 4. C is equal to b over 2 squared. What's the value of b? 8 divided by 2 is? So the equation would be x squared plus 8x plus and our set of parentheses squared would be x. Yep. X plus 4 squared. Because 8 divided by 2 is 4, so that's the number that will go into it. And it's plus because it's positive. Let's look at the next one. What's the value of b for number 5? Well, negative 2 divided by 2 is? Negative 1 squared. So this would be x squared minus 2x plus 1. What would our set of parentheses squared be? X minus 1 squared. And if we went through factoring x squared minus 2x plus 1, we would get the same thing. X squared minus 9x plus c. C is equal to what over 2? Does negative 9 divide by 2 evenly? No. So we can leave it as that there. That's perfectly fine. Negative 9 over 2 squared, well, the negative is going to come positive. 9 squared is 81, and 2 is 4. So we can say that this is x squared minus 9x plus 81 over 4. What would go inside the parentheses? X. Questions on this here? So this here, this method will give us a C value that will make it a perfect square trinomial every single time, no matter what the setup is. Which means we can use the square root method every single time and still get an answer. Because as we saw, the square root method on the first few, even though it was imaginary terms, we still were able to get the answer, yes? So that means that we can use this here. Now, there are some steps involved in solving this. The first one is a equal to 1, if not, make it so. Because again, we're dealing with equations that are ax squared plus bx plus c. So if the term in front of x squared is 1, awesome. If not, we've got to make it be 1. Get all the constant terms away from the variables and leave 2 spaces. Get the constant terms by themselves. Step 3 is find the value of c is equal to b over 2 squared and plug it in. Find the perfect square trinomial and solve. So we're looking at this here, x squared minus 10x plus 7 is equal to 0. because I would go through the other methods first, or really we can default to the quadratic formula, which we will learn this week, which is a little bit easier than this. But I would try graphing it first, because if I graph it and I get whole number solutions, hey, we have the answers, we can move on. But if it asks specifically to use completing the square, then we can do this here. Now, on the first one we did, we could see, can I rewrite this as a set of parentheses squared already? If not, we can just move on to the first step, which is saying, is A equal to 1? Yes. Our next step is to get all the constant terms to the other side. So we're going to subtract 7 from both sides. Because we want to remove all the constant terms to the other side, because again, we're turning this polynomial into a perfect square trinomial by adding that number in. So we'll subtract 7 from both sides, which leaves us with x squared minus 10x plus blank is equal to negative 7 plus blank. We leave space in there because, again, we're turning it into a perfect square trinomial. I need a little bit of space in there to plug back in the value of c. Now we said c was equal to what? Squared. In this problem here, what is the value of b? Negative 10. Well, negative 10 divided by 2 is? And negative 5 squared is? 25. And I would add it to the x squared and negative 10x, because that would give us a perfect square trinomial, yes? Well, if I add 25 to one side, I have to add it to the other, because we can't add something to one side without adding it to the other side, or subtracting, because we're trying to keep everything level. Because if I add 25 to both sides, I'm really not changing anything. Because another way that they put it is that you add and subtract 25 from the same side, because it's still just 0. Because we can add and subtract it from one side or add it to both. It would be the same thing. Now, over here, x squared minus 10x plus 25, we know that we've created a perfect square trinomial. So I can rewrite this as a set of parentheses squared. Well, it's going to be x what? Now on the other side, we have negative 7 plus 25, which is? Almost. We have to square root both sides, because we still need to get x by itself. Well, the square root and square would cancel, leaving us with x minus 5 is equal to? Almost. Plus or minus 3 squared root of 2, because anytime we square root both sides, we have to add that plus or minus. And last but not least, exactly, we're going to add 5 to both sides, which will tell us x is equal to 5 plus or minus 3 square root of 2. Now, because 3 square root of 2 is an irrational number, we can't just add those two together. We're done. Unless we want to turn this into a decimal approximation, I will take this here as your answer. Any questions on this here? This here is the first method that we have covered that works every time. Because no matter the setup of the problem, we can solve any quadratic using completing the square. Any questions on this here? We're going to look at one last one, and then we will be done for today, because I think this is the last problem on the note sheet. We have this here. Now, is a equal to 1? Yes. Now, x squared minus 18x plus 5 is not a perfect square trinomial, so we need to do some moving. We can subtract 5 from both sides. And that'll tell us that we have, try to keep colors the same, x squared minus 18x plus blank is equal to negative 5 plus blank. Because we leave the blanks in there for when we add back in our c component. Now c is what? Negative 18 over 2 squared. Because it's our b over 2 squared, the value of b is negative 18. So negative 18 divided by 2 is, and negative 9 squared is 81. Well, x squared minus 18x plus 81 is going to be what? X minus 9 squared, and negative 5. And negative 5 plus 81 would be 76. Our next step would be to square root both sides. Well, the square root and square would cancel, telling me that x minus 9 is equal to plus or minus 19 square root of 2. That seems a little big. Because 76 is, because 2 goes into it, 38, which is, I see what you're saying. I have it backwards. 2 squared to 19? Yeah. I heard it flip for some reason. I was thinking 19 squared to 2. And last but not least, we need 2. By adding 9 to both sides, which tells us x is equal to 9 plus or minus 2 square root of. And that is it. Any questions on this here? Your assignment is on page 140, 3, 5, 11 through 18. 3 and 5 are asking you to use the square root method to solve the quadratic. Now on both of these here, I will tell you the quadratic side of the problem is already a perfect square trinomial. It is already set up as a perfect square trinomial. So we don't have to do anything to it. 11 through 18 is you're having to find 2 parts. You're going to need to complete the perfect square trinomial. So find the value of c. Or really, it's just asking you to find the value of c and then rewrite it as a set of parentheses squared. So you're trying to find the value of c and rewrite it as a set of parentheses squared. And that is